Okay guys, so we're going to be looking at the IXL that you guys are going to be doing next week, all about the triangle inequality theorem that we talked about with the Desmos activity. If you're unsure what that means, it just means if we have three given side lengths, can we make a triangle or not? Okay. So these questions, all right, are basically going to give you three side lengths here, okay? And it's going to ask you, does this make a triangle? Yes or no, okay? What needs to happen is for a triangle to basically be a triangle, let's say we have our longest side here, and we have another piece here that we're going to break into two pieces, okay? If they're the same length, you'll never be able to bend it enough, you'll never be able to actually to make a bend to make a formed triangle. You're always going to have this weird overlap, okay? That's why we need two pieces, one that's long and one that's slightly longer. Because if we break it, let's say we break it here, we can take the first piece of our break and make part of our triangle, and we can make the other piece of our break the other part of the triangle. That's why we need the two smaller lengths to be larger than the other third length. Okay, so there's an easy test for this. All you have to do is take the two smaller lengths. You can see here 3 and 3 are smaller than the others, and add them together. 3 plus 3 equals 6, and then compare it to the last one. Okay, notice 7 is bigger, and since this one is not bigger, we're going to pick no for this one. Okay, basically like I did, just add together the two smaller lengths. If it's equal to or smaller than the third length, then you have to click no. Okay, here let's just do this one. 1 plus 10 is 11, and 11 is bigger than 10. Okay, notice 10 is the largest for both of them, so I'm just going to pick one of them and add it to the other smallest one. Okay, here we see some decimals. That's okay, but also notice with this one that they are not in the correct order. Okay, really this should be listed 0.7 if we go from smallest to largest, 9.1 and 9.8. Okay, we want to add these two. 0.7 plus 9.1 equals 9.8. Since these two are equal, it's a no. Remember, it has to be larger. It can be larger by 1/10, but it has to be larger. So even though they're decimals, make sure you're picking the two smallest lengths, adding them together, and seeing if they equal the biggest length. Okay, here we go. 1 plus 4 is 5. 5 is bigger than 4, so yes. 1 plus 4 is 5. 5 is smaller than 8, so no. Okay, 1.3 plus 6.8 is 8.1, which is larger than 7.7. Here we go. Now here's some different types of problems you're going to run into, okay? Make sure when you see this, you're looking to see not only what the two side lengths are that they're giving you, but also the largest possible, notice, whole number, okay? When we did the Desmos, we found the limit of those smallest and largest lengths, okay? What we're going to do here is we need to find the limit again, but then we need to go take a step down, okay? So what I would recommend for this is simply take the two numbers that they give you, underline those, 19 and 18, and let's subtract them. And this is going to give us our minimum. Okay, that is going to be, once we reach that number, we'll create a flat line. Okay, so we can't actually get that number. And the maximum is going to be 19 plus 8, should be 27. And again, that's just going to create a flat line. What this would really look like is, let's say the triangle length is x. So somewhere between these two numbers is going to be our side length with those two side lengths of 19. All right. Now, this one's the largest possible whole number. All right. Now notice, if we reach 27, again, we're going to create a straight line. We're not going to create a triangle. But if we just subtract 1 from this and get 26, 26 works. Okay? Since 19 plus 8 is 27, 27 is just 1 bigger than 26. Okay? So what you want to do is you want to find basically your range. Okay? Find your minimum or your maximum, whatever they want. And for the maximum, you want to go down by 1. You want to basically make it into this little range that they have. But you want to find the biggest number in that range. Okay? So here we should have 26. All right? Let's see if we can find another one with the minimum for that one. Okay? This one is a no. I'm just going to kind of go through these kind of quickly. Here we go. Smallest. Perfect. Okay, so now they want the smallest possible whole number. Again, we have 13 and 12, and they want smallest now. So let's do 13 minus 12. It's going to give us our minimum, which is 1. And 13 plus 12 will give us our maximum, which is 25. Okay, let's look at a number line this time instead of one of those things. All right, so over here is 1. Over here is 25. And all the way between here is where our side length can fit. Okay, the only problem is we can't use these two numbers. We need to pick numbers inside that range, anywhere from 1 to 25. Well, again, we want a whole number, so no decimals, and the number that's right next to 1 is 2. Okay, so we want 2. So this is kind of counterintuitive, okay? What they're saying is that if they want the largest, okay, what you should do is find the maximum and minus 1. Okay, that's going to put you right here, right inside the range, just one space away from the very limit. Now, if we want to do the smallest, okay, find the minimum, oops, and add 1. And that's going to put you right here. Okay? So remember, one thing too, this number always has to be positive. If you were to subtract and end up with a negative number, just drop the negative, okay? That minimum always has to be positive. Okay? Cool. So let me just do one more thing. Just grab a blank space here so I can write. All right, so just to summarize, okay, for most of the problems, add smaller two lengths, the two smaller numbers, and if greater than third length, it is a triangle. Okay, so remember, for majority of these, you're just going to add the two smaller lengths. If they're larger than the third length, then it is a triangle. If they give you the two small lengths, remember, if they want the smallest possible whole number, take minimum plus 1. Okay, take our minimum that we can find, like we found in the Desmos activity when we just subtracted the two numbers, and add 1. If we want the largest possible whole number, take the max and subtract 1. I know it seems a little counterintuitive. If we want the smallest, we want to add. If we want the largest, we want to subtract. But it's so that we can fit into that range that we talked about, okay? So that if your max is here, if your min is here, your max is here, you want to be right here, -1, or right here, +1. Okay? All right, hopefully that kind of clears things up for you when you guys get into this next week. Please make sure you answer those few questions after this, and I will see you on Monday or Tuesday.